Now it should be. Okay, so what we're doing is we're going to go through this one, the Xilinx ISE, but this one again has images from an older version, and what I'm going to do is try to do the exact same thing under a newer version, or the version that we're using now of Xilinx. So I'll be flipping back and forth, and that means for the DE students, you may as well just leave it on the big screen capture here instead of PowerPoint. Sorry, I've got to turn. Okay, so let's get started. Before I get started, let's look at this. Here it says practice exam. You guys in the DE class should also have that practice exam. It is, I would practice it. Let's make sure that you guys got it too. I would definitely practice that. Yes, it's open. I'm not going to give you the answers for quite a while yet. Maybe the night before, but don't save till the night before to study for the test. I promise you will not do good if you do that. I checked earlier on Moodle 1, I had that as an online test, like the quizzes for your homework. That meant nothing to the DE class because that's what they do every day anyhow. But for you guys, it would have meant that you could have stayed home and done the test or go to a lab and done the test. I checked before class. It's not there. So I'm not promising, but I'm going to try to get it back to where it's an online test. Of course, the good thing about that is you can do it wherever, and the bad part about that is that you could be dealing with Moodle too and have issues with it. So one thing I could do is split it up into like 5 different tests. So if you mess up, you only mess up a portion of it, right? If Moodle messes up, I can think about doing something like that too. Midterm exam parts 1, 2, 3, 4, and 5, or something like that. I wanted the exam to be before fall break, which is October 6th and 7th. We could still possibly make it, but I don't like to push things just to meet a random date. So that means today, next Tuesday, and next Thursday, and we got today, next Tuesday, and next Thursday, and then boom, we got an exam. It's possible. I think at this time, though, it would be better to come back from break and have an exam. Okay? So let's do it that way. The other thing I have to say to the DE students is in almost every faculty member's class, you have to have a proctor. You do not need proctors in any of my classes because all of my tests are open book, open note. I am counting on the fact that you're being honest and you're not working with a team of students somewhere, that I don't know about, and there's like 5 or 6 of you working together. I trust my on-campus students the same way, not to work together. So, so don't bother getting a proctor. It makes your life, my life, a little bit easier. Okay, let's go for it. Xilinx ISE. And they're going to play music next door again, aren't they? I'm so glad I can't hear well. In fact, if it gets too loud, I'm just going to take my hearing aids out, and that way I won't have to hear anything. This is what I plan to do, so let's get started. Here, when you first open it, we've seen this before, you get the tip of the day. That can be turned off. I wouldn't until you've kind of gone through all of them and seen them all more than once. Now, back in the day, we could just go through Mosaic to get onto Xilinx. Now we can't do that. We have to go to Mosaic, go to all programs. Oops, I'm sorry. Go here to Linux, and then say connect me, and then to any available server. So we're doing all this through a Linux server. Now, Rod Hatley keeps doing stuff here. And you guys have done this already, but you guys still, it doesn't hurt to see it. So I'm setting up that environment, and now I'm in Linux, or will be, and I'm going to pull this up, and you're going to see it looks pretty much the same. Okay, here in Linux, we click on the foot, go to Mosaic, go to Engineering, go to Electrical, go to Xilinx, and then down here the ISE Project Navigator. If you've done it before or used it at all ever before, the Project Navigator is going to bring up what you were last working on, whether you were done with it or not. And I left the screen, I think, like this. Nope. See, it pulled up my last, the last thing I was working on. So, but this looks a lot like this. Now, I didn't get the full screen, or I'm sorry, I didn't get the little tip of the day because I turned that off a long time ago. Okay. So here we go. When you first open it, you're going to see your most recently saved. I've just showed you that, right? This is the most recently saved. I got it under simulation, so if we go over to implementation, I could go back and double click this and see the circuit that I drew in there. Okay. That was from one of the earlier, that was from that lecture that got trashed by Panopto. See, UNCC has got this habit of buying the cheapest software there is out there. Not the best, but the cheapest. And so they managed to get the cheapest, and it works like the cheapest. I didn't say that, except it's on recording. Oh, shit, I'll just have to go back and erase it. Oh, I didn't say shit either. Oh, anyway. So, you see the most recently saved. We saw this window come up. I really don't care about that window. It just kind of gets in my way. So I normally go to Design Summary. I can turn it back on if I need it. I usually don't need it. So I go up here and I just get rid of it, or you can get rid of it clicking here. Message of the day. All right, next thing. Okay, you'll see this one if you've never opened it before. It looks like what I might have done, I might have actually gone in and gotten new images from the latest version. Okay, it looks like it, doesn't it? So we're going to open a new project. It is the newer version. Oh, good for me. I deserve a pat on the back, but I can't reach it. So anyhow, so here we're going to create a project. I'm putting it in the same area I put it before. I'm going to call it T6, and I'm going to say this time that the highest level is HDL. The last time I said the highest level was schematic. So let's go, and I might even cheat a little bit. If it's already there, I might just pull it up. Okay, so let's close this project, and it says we've, let's see, it says I've got one out there. What was I calling it? T6? I didn't see one called T6, did you? No, so let's see if I can open a project and go back to this one. Says it's in presentations topic 6 again, and then T6. So this, oops, wrong one. This is not that particular folder. Let's go up one, and there's presentations, and here's T6, or topic 6. Here's topic 6 again, and here's T6, and I should see only one ISE file. Now, this is why it's so important when you are transferring your project from one system to another. Look at all the directories and folders it's created. If I do this and tell it to look at oh, it doesn't do that, does it? I was going to say tell it to look at star. It's not doing that for me either. It should be finding all kinds of files in here. There should be tons of them in here. But this one, the T6 XISE, is the one we want to open. That's the only project file that's there. So that we open, but it pulls in all this other stuff that got saved automatically. Let's back up and migrate. I know, I didn't want to do it, but then it's like, what the hell? Go ahead and do it. Okay, this is an interesting project. Here we go. So we're in here. We've called it T6. I've done all these things. Told it that we're going to use a Spartan 3 board. It's that same device. It's the same package. It's the same speed. My synthesis tool, we leave that alone. Simulator, iSim, we do the same thing as all the others. The only difference here is we've started this time with an HDL instead of a schematic. VHDL is a preferred language. That's the only one I talk about in class. When we get all that, we hit next and we see that it gives us a summary. Basically the same things here. It says -4, so I must have done this in two different operations because the one right before this said -5. So anyway, it gives you a chance to verify. When you're done, you click next, or in this case, finish, and we should come up with this and an empty view here. This should say XC3S200 or something like that. That name. Let me go back a couple. The name of this board, and then this, and then the speed. So it's hard to see, but that's what it says there. Okay? We can get rid of this. We don't need this. Okay, the next thing. We go to Project New Source. Going to tell it it's a VHDL module. We're going to name it. I had somebody from the evening, or from the DE class, ask me where your test bench whatever that graph was. What was it called? I forget. Test bench something or other. They're not there anymore. This version doesn't have them. We have VHDL test benches, not any kind of test bench waveform, I think is what they called it. So here we'll go in here and we'll look, and we're at T6. Okay, that's where we're at. We opened up T6. I can, if I want to, bring up the first one, and here it is. This is the main structure of it, and here's a synthesis tool and a number of other things. I don't think anything will happen if I double click on that, but you can see here it's still the XC3 S200 and the 256 board. Okay, the we had called it. I called it this for the file name. I want to see if it shows that on the top, and it should right there. It's called the T6-VHDL.VHD. That's what I named this particular project. Here, it put it in because I put some of that information in. Xilinx fills it in for me. If you put as much as you can into that wizard that I'm showing you here, it'll put that in that file for you, and you make less mistakes that way. Okay, so we click next. Here, look what I've done. I put in X3, X2, X1, X0, Y3 through Y0, S3 through S0, and C out. And I told them they were all ins and they were outs. And I told it this was a behavioral. And I hit next. And when I did, it shows all this. It shows us that there are pins on there and that their inputs or outputs. And we say yes and verify that. Okay, so I think I got rid of this. And this window here is usually where we put the VHDL template. This window again is this summary we don't really need, and this one keeps up to date with what's going on in the system. So here it is. I did show it to you. This is the same thing I've got here. If I close this up, both are exactly the same thing. Now, as I said before, it put these two commands in there for us. We want those commands in there, but I don't want to have to remember them. So what I've told people before, if you have this habit of not wanting to use those wizards, then copy this and make it a template of some sort in some folder on your machine. But it's easier just to go ahead and use the wizard each time. It went ahead and called CN a CN, told it was an input, told it was standard logic. Remember I was saying the other day how weird this particular syntax is, because we say it's an entity, and that's the end of the entity. So this name of the entity and that name must match. Then the keyword is, and then we have port, and this is where we list all our inputs and outputs. At the end of each one, there is a semicolon, except the last one. The last one closes the parentheses for port and then puts a semicolon. So I don't care which one it is. C out could be up here and C in be the last one. Whichever one is the last one does not get the semicolon. Okay, and this is called an entity. Okay. Then here we got architecture. Now this is maybe a VHDL file I shouldn't have started with. Maybe. What we have here is, for this full adder, a 4-bit full adder, is we see a bunch of port maps here for a full add. It also shows us signals, it shows us components, shows us another port command and how to end this component. So this one's a little weird. Okay, so what we've done, let me open this back up, and I'll open up stage 0. Now here's you saw this the other day when we looked at that other one, that here's a standard logic for a 1-bit full adder. Okay, we have the S, or the sum output, is X, XOR Y, XOR CN. And then our carry out is X and Y, or CN and X, or CN and Y. So here's our architecture, and here's our entity for one stage. Well, what's really cool about this one, I don't think we can click on anything, and we may be able to see. I don't think we're going to be able to see um, a circuit or anything like that. Let's see. I don't want to create a schematic symbol. I don't want to mess anything up. But anyway, it does create a full adder. What we do in this one, and you can see it's the top level of all these different VHDL files because it's got this here. How do you change which one's the top level? Click on it, click right there. But this one, believe me, you have to have this one as the top level. If here's stage 0, and if we look here, stage 1, it should look like what happened.
I was going to ask you, how do you create the bottom levels?
These?
Yeah. Or are they created by itself?
Let's go back through here because I kind of strayed from this. This does tell you how to do it. So here's where I made the original file. I didn't put anything in here, but I said I was going to have all these. It automatically puts almost all of this in here for us, okay, except for the architecture. It just reserves spaces for that. So here is a VHDL template file for what we've got so far. The port maps are shown there. Okay. So the next thing, I do want to show you. This is interesting right there. But what it's telling us is we've got a component that's a subcircuit. So actually, we had to create another file, and instead of saving it as a full project file, we had to save it and tell it was going to be a component instead of an entity. And let's see if we can find where we've got that. We'll find it. It's in here. So it's similar to this entity, except we're saying it's a subcircuit. So as soon as I say component, and I start putting these components in, here's stage 0, it's a component. Here's stage 1, a component. How do I know that? Component's named full add. And here I say full add. Stage 1, full add. Stage 2, full add. Stage 3, full add. So when I get here, I can, if I double click on any of these, stage 0, stage 1, this isn't changing. It's because they're all the same component. They're all the same component. I use that. That's one of the real values here in VHDL. I've used the same component over and over and over and over and over again. But what I did up here, this thing, was create a port map. Now this is kind of weird. This port map down here for stage 3, by the way, is if we think of this line, that's the next space is this one here. It just didn't all fit on there, so I wanted to do it this hit enter and bring it down. But this should be right here, should be continued right there. Okay, let's go take a look at it. So here we've got a signal C1, C2, C3, and their standard logic. Now we're talking about the architecture again, and I want to go over signal. Have you ever had, for the DE students, I'm going to have to pull up Word. This is just to jot some stuff down on so everybody could see it. Have you ever had, let's say here's a, you probably haven't because of the way we're working with it, but let's say we have a circuit that is like that, okay? And I'm going to say shape fill is nothing there. Okay, then inside there, I've got some other kind of circuit, okay? And I might have even another kind of circuit from there, okay? And I might even have another kind of circuit from there. Okay, now anywhere that I have a line from the outside, this block here is called the entity. Okay, these are components. So I want you to see this visual part of it. Those are components. These are standard logic inputs. Okay. Then some circuits that you've worked with, now here we've got a standard logic output, but haven't you had some circuits where, let's see, we know this input comes in, right? We know that it's going to be a nice square thing. I'm not going to do it that way, but it's going to be connected here. This one's going to be connected over here. This one's going to end up connected here. Okay, so we've got all those, and since they're to the outside world, they're called the standard logic inputs and outputs. But when we have a wire that goes from here to here, are they playing some really weird stuff next door?
You have no idea.
Really? I'm going to get my ears out because this is weird. Okay, and here's another one. These are called signals because they're wires in the circuit, but I can't get to them. I can't touch them. They're inside the box. They're not. They don't ever get to the outside of the box. They're not an input or an output. Okay, so they call them. These are called signals. These are inputs, and this is an output. They always do it that way. So we've got these signals that are going from one component. We're going to see this in a minute, but it goes from one component. The carry out is going to go actually to the input, the carry in of the next stage, and then this carry out and this carry out. So we just called them C2, C1, 2, and 3. And here this port says this. Now this one's very important. CN, X, Y, S, C out is the order of those pins for the component. Now those are all going to end up being signals, but anything like here, like right here, let's look at this one. This is a stage 2 full add. Here's the port map. And this C2, you might be saying, well, what is C2? Well, C2 is the input to the second stage because of where it is in this list. X2 is X in this list. Y2 is Y. S2 is S. And this C out is C3 by virtue of their placement in this list. On the very last line, we connect things in the outside world to things on the inside world. Okay, so we connect input and output pins over to signals. Now here it's going to show that how these are mapped. CN is here, there's C3. Here's C out, and there's C out. And here's X and X3, and Y and Y3, and S and S3. So we go.
That's just saying that those are connected.
Yeah,
Being connected.
they are connected. Now, this is something I was starting to bring up the other day and never did. If we go back here and we look at that, is it this one? Yeah. We've got these. This to me, we can learn this. It's not hard. That's just some syntax. That's no real big deal. But another way of doing this whole thing is coming up with a project that is just a full adder, just stage 0, and then tell it to make a create a schematic symbol of that. And when we create the schematic symbol, we can pull that schematic symbol into a schematic diagram and connect them like we connected these here. We connect them with wires in that schematic setting. So it depends. What do you like to do? Do you like to do it through text and tell where is everything connected, or do you want to make schematic symbols and then tie them all together this way? It can be done either way, but that's why I'm showing this way, because most of the time in this class, most students won't do it this way. Okay, so each of our full adders, I wanted to show, I thought that was important. No matter which one of these I clicked on, I got the same thing, because they are all one component in this one. All right, let's go back. Okay, so we finally get back here. We're seeing that because, now this is, I don't know who asked this before. Was it Max? Okay. We created this. That was fine. When I said stage 0, full add, and port map, and put in this line, this popped up. Okay? When I said stage 1, full add, port map, and ended that line, this one popped up, then that one, then that one. Okay? So now we know that all 4 components are in our big entity.
So when we synthesize it, then it pops up, right?
No, wait, I'm not sure if I don't think I've synthesized anything yet.
Also, just like
I think you just enter it and then it pops up. As long as this knows what the component is and this knows what the signals are, when you type in this line, it should pop up then. But I think we still have to synthesize. I don't see any green X's anywhere in there. Okay, so now we go to the VHDL module. This is how we created all the full adders. We didn't tell it was a, no, we did tell all the other ones that it's VHDL module, but this one, it's just a the full adder. We do it all just the same, CN, X, Y, S. The other one had 4 of those. We have just these now. Hit next. Verify, click finish, and now it's asking what do you want to do down here with this full adder. So we create it. Okay, it's still entity, it's still end, so this could be used by itself, but when we pull it into the full adder as I'm sorry, by putting these lines in here, then it pulls in that full adder that we created and puts it right there. Okay? Now we click on synthesize. And when we do that, it should pull all of those together. Now let's go over there and actually synthesize. I hope this was done right. It is some weird music. Is that music or is that people talking? Okay.
Sounds like a kid.
Synthesis executed or completed successfully. So that's a real good thing. I can come down here now and view technology schematic. This is something I do want to show you. I always do this, start with the schematic of a top level block. There's my full ladder. See my inputs and outputs? Here's my inputs, here's all my outputs. It's not showing anything that is a, sorry, my brain just went blank. The components. So I double click on this, and now let me zoom out a little bit.
There's the Zoom fit.
Look what I got. Stage 0, Stage 1, Stage 2. They show them as lookup tables. It shows all these. Everything's going to have an input buffer, and everything's going to have an output buffer. Okay?
Oh, these are buffers. Okay, I thought they were, like, whenever I looked, I thought they were all inputs.
No, they're all going to have just buffers there. Now, the other thing it does is it connects this CN, and we're going to go back to that in a second. It goes to this line. Let's see what we can, if we can get in there and find out. It says it's I2. That was CN on the first one. Shoot, that doesn't really help us. I0 is down here. Here's X0. Here's Y0. Here's CN. So I believe if you go back here and look at that, it's that first lookup table is our first component, and it's connected like this, and we can see that in this full ladder where the C out is coming from here, then here's our CN's going there, and our X and our Y is going there. And then we got X1 and X and Y1, and this one's going over to there. So it's starting to show us what that what those components look like. And if I wanted to, I should be able to go here and somewhere in here I should be able to see what the component itself looks like. But I'm not sure exactly where that is. I'm not seeing it right now. Okay, so we can look at the technology schematic to get that stuff, and we start with this. And I was already told you that. It already showed you the full ladder. It already showed you all this. So it's kind of showing that the components are broken into two parts. What I really wanted to note was, see all these red lines? These are all signals. You can define signals in any one of yours. You don't have to have components. You can have signals. But what students have done in the past is they've started I've seen them do this, and I've told them not to. I've seen them have something like this, and they know that this one's an output when they're creating this, so they call it an output. But it's an input over here. So they get an error on it when they call it an output. So they go, okay, I'll call it an input because it's an input here. They get an error on it because it's an output from there. So they go, I've seen that other one. It's called an in-out. And they say, I'll use that. And guess what? It gets rid of your error. And it's wrong. It causes all kinds of problems. Okay? So what it is a signal. So you have to call it a signal. But everyone's tempted to use that in-out because it's right there, right in front of them. When they try to switch from in to out or out to in, they see the other one there saying in-out. And they say, I think I'll try that. It won't work. So you have to be able to call these signals. Okay, here it's showing the first lookup table. Okay, it is showing the first equation, it's showing the first truth table, and the first Carnot map. These are all of those components. They all look almost exactly the same. When we get to some of the LUTs that are out there further, we get some pretty crazy looking ones. You know, the ones that say XOR, nope, not this one. The ones here that say XOR, where are they? Sorry, on the full adder. This one, XOR and XOR, that's, it's hard for me to keep up. That's just kind of a, when you see a lookup table that looks like this, you're looking at a XOR type thing. Okay, to look at the RTL schematic, same kind of thing. Now, this one may be a little bit more interesting to you because let's get rid of this and go back full ads here, and we click on View RTL schematic. Again, start with the top level. Here's our adder, 4-bit adder, and now it's showing us the full adder with C in, X in, X0. Then it shows that C out is connected to C in. Now this is very clearly a signal, right? It doesn't go to the outside. The green line here is the outside of the box. It does not ever go to the outside. It stays in here. If you could touch anything that was on the input or output, you still can't touch this line. Okay, so it shows you the full adders that are in there, and it shows you which ones are the signals.
So is that what you're talking about whenever they try to use the in-out?
No, no, you don't get this. It causes the in-out causes trouble.
No, that's what I'm saying. That's what they were trying to make that connection right there.
Right, they're trying to make it that. But what it is you give it the word or the name's signals.
So the signal is what connects the interior of the component.
Yeah. And see here, a port has to be an input or an output. A signal, it doesn't say anything about being in or out. Not a thing. Okay? Now here we're looking at what our port is going to be for each one of these, and it defines these as inputs or outputs, right? It showed that right here. But C1, C2, and C3 isn't a part of this component for the full adder. So there's 4 stages, and let's double click on that one. And we see the schematic for that, and then this is a multiplexer and XOR, I believe, and I don't think you get to go any further than that. So this is just a confusing bunch of wires and stuff. Okay, but it does show that all that's in a full ad is this, and all these things are signals. All those that are in red. So we don't really need those, but so I like that RTL schematic better just because you can see the 4-bit adder, and then when you double click on it, you can clearly see one full adder and where all the signals are. It makes it very, very clear. Okay, then we get down to here. That's the XOR thing. You can see this. Here's our AND gates and OR gates and put them all together. So we can find that circuit that we described in the full adder if we want to. Let's see. So do we want to verify this? Now I did this. I don't remember if I did this one on purpose or not. I did make a couple errors and they pop up. Now I'll do this on my slides. If I create an error, I'll put it in there so that y'all can see it. And then you get an idea of uh, how not to do that. I think there was one that I actually put them in on purpose, though, just to see what kind of errors we got. You see all these purple lines down here? You see that question mark? We know we got troubles, okay? And here it says 2 errors were put in the file. The semicolon was removed from here, so that was one, and C1 was removed from this list. Okay. I could go do that, but I don't really want to. So let's see where that is. I took this, nope, sorry, I went here. I took this semicolon out. So it gave a really weird error. I can take it out. We can look at what the errors are. If I take that out, save it, and look, we get all these errors. Okay, I didn't even have to tell it to synthesize. But if I do, I'll get a bunch of errors. What did it say?
That's just one semicolon, and it gives that many errors.
Oh, yeah. And here it says it failed, and here's starts listing all my errors are in there somewhere. So it just failed. And it's because now, because it's such a free-flowing language like C and Java and some of the other ones, you come in here and now it sees signal C1, C2, C3, colon, standard logic, component, full add, port, blah, 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 to this semicolon. It thinks that's all one line.
Oh, so the semicolon just ends the line. It just
And
says, okay, read this and stop here.
it said this is a bunch of garbage. So we put that back in. I resynthesize, and it should come up that everything happened just fine. Please, everything happened just fine. I hate it when things don't happen just fine. But we got our green check mark. Now, that also said that these were connected by those signals inside that full adder. This is our CN from our very first one. Let's go to this and go back to RTL. CN, CN. And that happened because CN is placed right here, and on our component, CN is the first one. Here I've got XO and YO, and here X and Y. Here's adder 4, X and Y. It's connected to X0 and Y0. It's connected to those by virtue of its placement in this line. This sum 0 is connected to there, and this C1 is connected to this C out. Now, if you look, this C1 is also connected to this C1. So this C out is getting connected to this C in by virtue, again, of their placement on the lines. So, what do you think happens if I take away C1?
50
Yeah, 3,000 errors.
We might get a few. What happened to them all? Oh, here's my error screens. Here's my warnings. It's not, okay, let's save it and see what happens. It just says, well, okay, so now let's synthesize, and we're going to find some errors now. Oh. And see, the thing is, we got a warning. It only gave us a warning, but it's more than a warning. C1 is used but never assigned. Well, what the?
And then it says unconnected output. That's awesome. It actually tells you.
Unconnected output port C out of component full add. And it does tell you line 56. So it is telling you it's right here. That's actually the best warning or error I've ever seen. Most of them are like, if you look somewhere in this file, you'll see something that doesn't look right. And that's really what most of them are like. But let's go look at the RTL schematic, and look what it shows us. It's got some real interesting connections here. Our C in, X, and Y went where it's supposed to. This C out was supposed to go here, but this doesn't have one, so it grounds it. It makes it always 0. The first carry in it thinks is here, and it makes it always 0. And this carry out doesn't go anywhere because we didn't tell it to go anywhere. So we have to tell it again right here. And what was it? C1. Okay, so if I save that, and I believe I do have to synthesize it again before it'll come up properly on my RTL.
So does it actually try to build it? Does it actually try to, like, whenever you synthesize, did it actually try to build it without having it? That made it a little easier to try to troubleshoot if it doesn't have a connection going somewhere. Like, oh, that's what it is.
Okay, so here are some of the ones that I got. I didn't look at them. The ones that we got when we just took out this semicolon. We can go back and do that. That could be a little bit of fun. Remember when I took this one out and then hit save and there were bunches of them? Let's go to errors and look at all these. Okay, now this is a more typical kind of error. Line 51, syntax error near component.
So that's all.
The problem's up on line 50. There's no semicolon, and it's saying line 51, syntax error near component, and then 52, syntax error near n. There's no syntax error near n on line 52. Syntax error near out. Syntax error near these parentheses. These are the kinds of errors you normally get. It's like, okay, well, it's up to you to figure this out, and you'll figure it out. What I always do on that is I look at the first one, and it said it was near here. So I start looking on this line. If I see nothing wrong on this line, I start moving backwards, because it could see this as part of that line. If that's not it, it could see this as part of the line. Until I see semicolons, that's where I usually stop.
Another way is just, that's where it started from, right? So it must be around there somewhere.
Mm-hmm. And that's all it can tell you. All right. What else have we got here? I replaced it. Everything was all right. I got this. I already showed you that. And so this was the first time. I was teaching myself Xilinx at the time. Okay, and so I was a little amused with some of the problems here, and I was probably being a little bit of a smart aleck myself. A test bench generation, I did not change this. This is just like the old ones using the test bench. They don't have them. Okay, so now we got to do it a little bit different. And we're going to use, you want to do it on the whole adder 4, okay, and not just that one. And it should be in there so that if I actually do this and switch over to simulator and I look at add TB, that's what I called it, and VHD, when I created it, it did all this stuff. It likes to put in stuff about clocks, so watch for those. I didn't have a clock in my circuit, so I put 2 of these in there, 2 dashes, so it'll comment that out. Then it shows how the port map's supposed to be there. I got rid of all this stuff that is related to a clock. And this is basically saying that we've got a clock where it'll be assigned to 0, and whatever the clock is will be assigned to 1. And we wait for clock period, whatever that happens to be, and divide that by 2. So this makes a 50% duty cycle on our clock. Okay, we can change that. Here, I'm going through and I'm putting values in. So I'm putting values in for X0 and Y0, and they're going to be added. And then I'm going to wait, and I'm going to put some values in. So anyway, if we run it, right, iSIM should come up. And we'll see what the inputs are and what the outputs are. Now again, as usual, we get this elaborating. I guess I haven't elaborated enough.
Can you just say processing?
Okay, now let's look at what it shows us. It'll do this every time. Give us a bunch of green lines, and you know that's not true. If it's green, that's good. If it's orange or yellow, whatever you call that color, that's not good. Those are all warnings. This one says zoom to full view. So as soon as you come into it and see green lines, zoom to full view, and now we can see what's going on. Okay, so our first carry in, there was no carry in. We had X0 and Y0 and added those and got sum 1 was equal to a 1. And then that should have been carried in, and we have X1 is 1 and Y2 is 1. And we got S2 is equal to a 1, and the same thing here. So anyway, I'm throwing in some values to see if they work, and this should show you that it worked just fine. Okay, I always like to establish that at the end. So any circuits that you do for me, the next thing you want to do on this, and it should work, is I'm going to hit Alt print screen, and that should pull up just this window. But right now I'm in the Linux. So let's go over to the Windows, and let me get out of this for a second, and come into Windows again. Where is it? And I want to go to Paint. And if I hit Control V, I get that whole thing. So at any time, I can now move this over. I can get at minimum this is what I want to see for, let's see, where's Paint? So that does sound like it's getting kind of weird over there. Okay, so now that's all I need for your results. Okay, for a lab or one of our projects, that's all I need for results. Now you might need to label some things to tell me what each is. Okay, and you can do that either in Paint or Word, or the one I think is the easiest to use, you might not think of it right away, is take this image and pull it into a PowerPoint, and use PowerPoint to do your drawing of this is this, this is this, this is it, and you can put lines wherever you want. You can do that in Word also, but if you're not if you don't use Word properly, when I get it, those lines have moved, and then it doesn't look right anymore. And if I type in one thing to make some kind of comment on your project report or your lab report, it moves everything around. And now nothing's right. So what I would do is pull it into PowerPoint, put all your stuff in there, then do another screen capture of that and capture this all as one image. It'll actually save you time. Because when I get to it, if those lines aren't in the right place, I'm like, why are these all scattered all over the place? Why aren't they in the right place? So, and I have learned over the years that it might be better for me to go and take a quick look first and see if everything's in the right place. Okay, so we've done that. Did the test bench. I got rid of the clock. It tells you all about that. Got rid of all those for the clock period. And then here's where I put in the data. Okay, and it would be real good to know what you think you're going to get. And then we hit double click on simulate behavioral model when this button's highlighted. If this button's highlighted, we're looking at the circuits and stuff and the VHDL. I show the ISIM window and show hitting to full view and the values that we got. And I try to show here that we had 1 plus 1 was equal to a sum of what? This is sum 0 was 0 and sum 1 was 1. So I had 1 plus 1 is 2. And here I had a 2 plus 2, I think is what that is. And here it shows up as a 4 because that's bit 0, bit 1, bit 2. Okay? All right. Somewhere in here, okay, I've got a little bit more to go, and then we're done. Then we download to the Spartan board. Okay. Now, there's a lot of little things that are going on here when we download here. The first thing you got to do is create what they call a constraints file, and they're going to call it a UCF file, a user constraints file. Some of you have seen this if in the lab. Where it has a pound sign, it says it's a comment. So those have all been commented out. This is just a template. Okay, but I want to hook up LED 0 and some of these switches so that I can put in some numbers like 1 and 1 and see if 2 comes up. So I start connecting these to the board. LED 0 should be, let's see, somewhere in here. Where is it? Somewhere in here I'm telling it in here that LED 0 and LED 1, LED 0 is going to be connected to K12. And if you look, it's hard to see it, but that's K12. And here it's got some values too. So it tells me this one's going to be used as my LED 0 for my bit 0. And when I did this, see here you can see K12, P14, L12, N14. They make no real sense on what those are called. Okay, so here are these switches. I set them up too. And what I wanted to do was, okay, I had SO went to LED 0, S1 went to P14, S2. These are my sum buttons. Go to these lights, and then the last C out. And then my input switches were, I had 4 on one side, 4 on the other, and the push button, since I ran out of switches, my push button was a carry. So I did all this, and you add it to the whole project, and then you can download all this to the board. And this, DE students, we're not going to do this semester. We'll do it in the lab. For us, we're going to do it in the lab tomorrow. Create the thing. We're going to implement the design, generate the programming file, and download it to the device. Okay? Now, when we download it, we got this. We connect the JTAG. And I did this on, it was an accident again, but I decided to put it in there. Uh, I I connected this, made sure that the JTAG where this line and this thing said the same thing, okay, so that it was on there right. This went to the, we've got a very few that are USB, the rest are parallel port. Very few computers have that anymore. Then when we say configure it, it wants to go down and go through all this stuff, and we'll go through it tomorrow in the lab on how to download it to the actual board. And then we finally get it down to the board. Now, finally we get this to succeed, program succeeded, and then I went down here to my X and Y switches, and I said, X, you can't really see it, but I pushed the 1 up and the 2 up for the Y, and I see that my result was 3. So that was good. And then I put a 4 and a 3, so I should have got 7. And what did I get? I didn't get 7. The result was 11. And so it's like, okay, now I've got some errors, and I know there's no errors in my VHDL because I've already simulated that, and that came out right. So it has to be in the UCF file. And I finally came up here and I looked, and I had 2 S2s. Okay, so when I got rid of that and put S2 and S3, and I did get lucky. That's why I was saying here I got lucky on finding that one. That S3, I put it in, re-implemented everything. When I got 4 and 3, I got a 7. I put in a carry, and I put some numbers in there, and I got the right, or the 4 and the 3 and a carry, and got 8. So I was happy there. All right. I know that was quick, but you should be able to see the videos if you want to go back and watch it any slower. And let's get out of here for today, and then we'll talk more about a possible midterm exam soon as we get through some of this stuff.
I just wanted to make sure that we're good for you to unlock the class.
Yeah, give me just a minute and I'll come up there.
Oh no, I've got a class. I don't.
Oh, well, I won't be here then, because I'm going home now. Somebody will be around. Rick will be around. Somebody will be around to open it up.
We don't get out of here until I don't get out of class until 4:45. So I'd be here about 5. So I'm gonna be.
I hope so.